So what this statement or what this line of code in the entire program of your C++ will do, basically it will make a variable named salary. The data type of the variable will be integer, and 85,000 that you have written on the right hand side of this equal to will be stored into this variable called salary. I hope this is very clear to you. Now moving on to this example, we have one more variable called float area. So the name of the variable will be area, and data type for this variable is float, and the value that we are trying to store into this variable called area is 64.74. This was for this line. Moving on to the next line, we are declaring a variable called volume, and this time we are using a double data type. So double volume is equals to 134.64. So as you can see, that we discussed in point number 2, the precision for double data type is very high compared to what you get in the float data type. So how can you judge about precision is by looking at the number of digits that you can use after the decimal point. This is the very basic fund of precision and accuracy that you learn in your high school mathematics. So the precision can be very clearly seen from the number of digits that you are able to use after the decimal point. School mathematics. So the precision can be very clearly seen from the number of digits that you are able to use after the decimal point. So these are some examples for float, double and integers. We can also use these two data types for exponentials. I'll show you one more example how to use them for exponentials. So here, as you can see, double distance is equals to 45e12. Now let me explain this line of code. Here we are having a variable called distance. The name of the variable is distance. Now as already discussed, the rule is before writing the name of the variable, you have to first mention the type of the variable. So the type of the variable is double. So distance is the name of the variable and it is of the type double, and on the right hand side of